So hello everyone and welcome to today's session Ask AuxEn Anything. And as you all know that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any RCC steel design concept or any project that they are doing or construction site issues. So this is the 66th such episode that we are conducting, and let us begin by taking the queries that have been asked for this week. So we'll start by taking the queries from Google Form, and then we will take the queries from email and live audience. So first query is from engineer Nishant Kumar. He is a working professional from Dhanbad, independent consultant from Dhanbad, and he is asking, kindly throw some light on how to model and analyze curved beams. So curved beams are nothing different from straight beams in terms of their design. Okay, whatever you do for straight beams, the same thing you need to do for the curved beams also. Curved in plan, I mean. So, and design procedure wise, nothing is different. The only thing is that when a beam is curved in plan, you will have your moments, you will have shears, you will have torsions also because of the curved shape in plan. So you want to basically capture this torsion in plan view. So for that, you can just model your curved beam. And if you're not able to model a curved beam by using arc elements, the easiest approach is to model it using small straight lines. Okay. So when you model it using a small straight line, you can get an effective curved beam shape, and because of the geometry that you create, you will get the desired torsion and you will get the other behavioral aspects. So what you should do is you should try and modeling it as a in terms of small straight lines. Okay, because what happens in StatPro, for example, StatPro is not able to give you design results for a beam that you have made curved in plan. ETABS is able to give it, but STAT is not able to give it. So the best way is to model your curved beam as in terms of small straight lines. Doing that, it will capture the required analysis results also. And design anyway, the design process remains the same, whether it's a straight beam or a curved beam. Okay. So this was his query. Next query we have is from engineer Aditya Raj Mehra. He is a working professional from Delhi. So his question is, I think he has asked two questions. Wind load, monoslope roof of rectangular building, monoslope free roof, freestanding double slope roof. So what is the query here? What is the query? Next question he is asking, base plate thickness without stiffener and one side stiffener, other side not. Again, what is the query? I'm not sure what the question being asked is over here. You have just made statements. How to apply? Oh, so applying you need to go through the you need to go through the wind code IS 875 part 3. You will get the required figures. I will give you a good document which is called as wind 06 document that has a lot of solved examples. Uh, that has a lot of solved examples for different wind cases. You will also get it online if you just enter wind 06 solved examples W06. Just enter this online, you will get this document. It has around 28 29 solved examples, and you could go through them and perhaps you will get a good idea. Okay. uh, in his second query, he is asking base plate without stiffener and one side with stiffener. Calculation base plate without stiffener. For calculation of base plate without stiffener, you go to IS 800. I'm forgetting the clause number where they have given the column basis. They have given a formula for gusset plate thickness. Sorry, they have given a formula for base plate thickness without stiffener. So you just go to that formula. It is an IS 800 code where you get the column basis. Okay. Mr. Shubham Singh is saying in relation to earlier question how to model horizontally curved beams. Yeah, that's what I said. You make there are options in ETABS to use arc. This is curved beam plan view. There are options in ETABS to make a curved beam in plan using 3-point arcs or 2-point arcs. But I am saying don't go for that option. Instead of that, model it using small straight lines. Okay. Yes. Mr. Mohammad Farhan is asking what should be the stiffness modifier for curved beam in ETABS? The same you take for normal beams. Why do you think curved beam is any different from a straight beam? I'm not understanding. Curved beams is not anything different from a straight beam. So whatever modifiers are given to you in for normal beams, you just take the same for your curved beams also. Okay. All right. So this was the query from engineer Aditya Raj Mehra. The next query is from engineer Allah Baksh. He is a working professional from Hyderabad. He is asking when then 50 mm contour type fireproofing is applied to a structural member, resulting in an increase of 100 mm in overall section dimensions. Does StatPro account for increased size while computing wind loads? I don't know. I mean, softwares on their own are not able to calculate the wind loads so well. It is just that you should calculate the wind loads on your own and then apply those wind loads on the software. So do not, I mean, I'm not sure if at all any software is able to calculate the wind loads on their own. Okay. So wind loads, any kind of wind load, if you want to calculate, if you want to apply rather, you should apply it on your own. First calculate it on your own and then apply it. So I don't think STAD will be able to account for this increase while because STAD or ETABS does not calculate wind loads. Please understand. Just like they calculate earthquake loads, they're not able to calculate wind loads on their own. So you have to apply the external coefficients, internal coefficients. In some cases, you may have to apply the wind loads on diaphragm. So as a user, you will have to apply all these things. Then Mr. Allah Baksh had asked another question. He is asking, please explain the design philosophy for this kind of beam. I'm not sure what design philosophy is being asked. It seems a simple, I mean, they have taken this cantilever. So they have taken a 6 feet cantilever and then there is another cantilever sort of resting on this. So what you can do in such cases is, because this 6 feet is, you make it very stiff, because anyway it's a small span, so you make this very stiff. Okay, it will be like a bracket for you, and then on that bracket you can have this beam as a 20 feet beam resting on it. So this will not be a no, don't treat it as a cantilever, you treat it as a beam resting on bracket on one end and column on the other. So here is the column and here it is the end of the bracket on which this 20 feet beam is resting, and take this as a cantilever bracket. So make it very stiff. Stiff means have its size provided in such a way that it is able to act as a support for this 20 feet beam. So this is what you can do for such a situation. Okay. Then next question is uh, Engineer Aditya Raj Mehra is asking types of slab, cantilever slab. Please clear doubt. What is the doubt? You are not in your queries. The doubt is not clear. What is the doubt over here? Cantilever slab is cantilever slab where, let's say, only one edge is continuous, and if other edges are discontinuous, you generally tend to call it as a cantilever slab where the behavior will be more or less one way, and this edge is continuous. It has a backspan, and other edges are free. And where the bending would be essentially in the direction of the cantilever, that type of slab you would call it as a cantilever slab. One side, two side, four side supported. You go to table 26, okay, of I think IS 456, and exer is I think D, if I remember correctly. In that they have given a table. In our courses also we have discussed these things in great detail. It's not just one side two adjacent, no, one side discontinuous or two adjacent side discontinuous or two opposite side discontinuous. So if this is the uh, let's say slab, and all these are slab panels, then this is my interior panel, because all slabs have, on all edges there are slabs, on the adjacent, I mean on all edges there is a slab. So all four edges there is a slab panel connected to it, so this becomes an interior panel. Suppose I have a situation where this is the situation, then I will call it as two, let's say two edges discontinuous. Now if it's a long span, then I'll call it as a two long span edges discontinuous. If it is short span, I'll call it as two short edges discontinuous. If I have a situation where I have a slab panel like this, then I'll say that this edge and this edge is discontinuous, so I'll call it as two adjacent edges discontinuous, and so on. So you read that table 26 and it will be clear to you. Okay. Then the next query is uh, from Engineer Shiva Ramakrishna. He is a postgraduate student from Tirupati. He is asking, suggest me any references for the foot over bridge design. So you can go to IRC 6, which covers the issue of bridges in detail. If it's a steel pedestrian bridge, then there is a IRC SP 56, which talks about the guidelines on steel pedestrian bridges. It's a special publication. And other than that, we have done a course on steel pedestrian bridges. And other than that, I'm not sure about the uh, texts or books to refer to. So I'm aware of these codes, and yeah. Two side support slab type, slab name simply supported or continuous slab. No, in all these cases, if it's a simply supported, that means if there is a individual slab panel which is resting on beams, and there's a individual slab panel where any of the edges is not connected to any other slab, then this is called as a simply supported slab panel. So you have got a different table for this. I think it's table 27. Okay. So simply supported slab panel, you have got a different table for it. Two side support slab type. Yeah, two sides, either it can be two adjacent sides. So these are continuous sides, these are discontinuous sides. So it can be two adjacent sides discontinuous, or as I made this diagram, where let's say I had this slab panel over here. Now these edges are continuous, these edges are discontinuous because there is no slab panel. So now these will be called as two long edges, two short edges discontinuous. This slab panel will be called as two short edges discontinuous, and so on. Okay. Then we have next query from, let me check email. He has shared this image from our course on steel design, and his associated query he has put over here. I'm not able to understand that for pure shear case, why these four brown bolts will come under tension. So you are saying if this is the pure shear in this beam, so because see, because what will happen is that when there is a shear force in this, when there's a shear force in this, it is trying to, let's imagine it's trying to fall down. Okay, so who is resisting it from falling down? If let's imagine that this is not connected, this web is not connected, and it is just resting on this, then who is trying to let's say holding it from falling down? It is these bolts. So if my shear force is downwards and these bolts are trying to hold it down, they will have tension forces generated. Okay, they will have tension forces generated. Now on the bottom bolts, yes, there is a bearing action that is happening. So on the bottom bolts, if you see, technically it's a bearing action, because on the bottom side, this bottom flange is bearing on this angle cleat, and then this angle cleat is transferring the forces through this connection to the column. So technically speaking, on the bottom bolts, it's a bearing action that is, I mean, on the bottom bolts, there's no direct tension. It is under bearing. But then why are we considering this also be to under tension? Because in cases of load reversals, for design purposes, we will say that these bottom bolts are also to be checked in tension. So if it's a load reversal, let's say, and the shear direction reverses, then these bottom bolts will come under tension, top bolts will come under bearing action. So if it's a bearing, you might not check it for anything, but in tension you should be checking the bolts. Will you please clear up my doubt if it is if possible? And also I think this is a moment connection. See, moment connection, generally your connection can take moments. Your connection can take some amount of moment, yeah, but what you need to understand is whether it is acting as a rigid connection or not. And by rigid connection, I hope you understand what I mean, that the angle between the beam and column should remain, the relative angle between beam and column should remain the same before and after deflection. So it might take some moments, but it might not be a rigid connection. So that is what you need to understand over here. Okay, is it clear? Yes. So this was the query. Now let us take the queries. uh, Mr. Raghuvir is saying, in fact, this is not a shear connection. This type of connection is for moment resisting connection. Again, I would like to clarify the statement that Do not call it any kind. See, even if you have a connection like this, where you have a web cleat connection, even this connection will resist some movement. So if it is resisting some movement, you can call this as also as a moment connection. But please what understand with caution that whether a connection is a moment connection or not, it's not of your interest. What should interest you is whether it acts as a rigid connection or not. And if this connection, in this connection, if the web is not connected to the column flange, it will not act as a perfectly rigid connection. Okay, you will have to add a plate over here, and then it can start acting as a rigid connection. Okay, all right. Then let's take the queries from the live audience. Photo-based design I've already answered. Mr. Vineet Kawadi is saying how to design a composite column. I have never done it myself, so unable to help you with it. You need to refer some texts on composite designs. We have a IS code also now on composite designs. I'm forgetting the name, but there is a code that is dealing with composite columns, composite beams, and Exer I of AISC 360 also deals with composite designs, so you could have a look at that also. Other than that, there is a book by RP Johnson, which is a good book on composite design. You could have a look at that as well. Okay. Mr. Venkatesh is asking, when assigning the parameter in stat, do we need to calculate the k value manually, then to assign in ky and kz? Then to assign in ky and kz along with the actual unsupported length in the model, in which case we assign unt and unb. No question. I have not understood what you are trying to ask. See, either you assign the lengths ly lz, or you assign the uh, k values. Okay. And in case of stat, in fact, if you are using the AISC code, the KY KZ is for compression buckling due to compression. KX is for torsional flexural torsional buckling, and UNB is for lateral torsional buckling. So in stat, if you are using AISC 360 for design, okay. So if you are asking for AISC codes, KX is for flexural torsional buckling. Then your KY/KZ is for, let's call it as flexural buckling due to compression forces. And then UNB is for lateral torsional buckling due to bending. So all are different. These three are due to compression loads. These are due to bending moments. So you have to assign all. You have to assign all, because all the parameters are for different actions. In our design course on AISC that you have taken, steel design course on AISC, we have discussed this aspect in great detail. So you can go through those sessions. Mr. Mohammad Farhan is saying, can you suggest a book for RC design which covers international codes and it is practical and it's for practical design? I have a few books which are there on ACI codes, but I don't know which one is good among them. But I have a few of them, but I'm not sure that which is the better book amongst them. They are all, I could find them almost to be similar. So I'm not getting the names. I also had searched it on the internet and I just downloaded them. Mr. Shiva Ramakrishna is asking, in which situation the hunch connection or knee connection used in PV frames. So if you want to, because at the ends of your column and rafter, you have a lot of movements, and because this connection you want to make it sort of rigid, so sometimes we can go for a haunched connection, HAUNCHED, haunched connection over here, or you can add bracings over here. So because there is a large concentration of bending moments at this junction, uh, you do get, I mean, you need to somehow uh, create a geometry which is able to take these large movements, and you also want to have a rigid beam column connection. That's why this haunch type of connections may be preferred. Tell me about your training modules on steel structures. You send me a message on WhatsApp, I will give you the details. All right, so I think this is all for this session. We have no further queries, and I also need to Mr. Nishan Kumar is saying, can you please show a sample curved beam modeling in ETABS? I don't have a ready model with me, but this, what I explained, should be enough. You try doing this. If you face some doubts, ask your query in the next weekend session that we conduct. Okay. Knee braces or haunch connection, what makes different in performance? Question not understood. Knee braces, haunch connection is mainly given at the rafter column junction to ensure that this acts as a rigid connection, and also because at this location you require larger cross section because of more movements, so this haunch helps you do that. Knee braces are braces actual members, and these knee braces are in compression, so they help you to basically lower down the span and lower down the bending moments at the rafter ends, and also lower down the deflections. So knee haunches will have smaller dimensions in the horizontal. I mean, they will have smaller horizontal dimension haunches. Braces you will provide it at a larger distance or a greater uh, distance. Okay, so I think I'm going to end today's session over here because I have to rush somewhere else. So you can continue to put your queries in the Google form. The link for Google form remains the same. And as you know that once every week when we meet, you can we discuss all those queries. So this is the link for the Google form. And if you want to connect with us on WhatsApp, this is the link to connect with us on WhatsApp. I'll just share it over here. Yeah, so this is the link for connecting us directly on WhatsApp. So that's all for this session then. Thank you very much. And you can continue to put your queries in the Google form. We will now meet you next week when we will take further queries and have our next session. Until then, have a good time. Bye bye.